Hi, welcome. Now I'm going to show you how to use Excel to solve a transportation problem. Okay. So what I'm going to do is I will formulate the problem, then I will explain to you how to solve it. Okay. The problem which I have taken here is we have three plants which are all the sources for producing a product, and the product may be a bike or car or whatever. And also we have a major distribution centers, DC1, DC2 and DC3. Okay, each plant A and B and C also have a capacity to produce. Plant A can produce only 50 cars, plant B can produce only 70 cars, and plant C can produce only 30 cars. Okay, similarly for DC1, DC2 and DC3. Okay, the demand for a distribution center is DC1 is 70, the demand for DC2 is 30, and demand for DC3 is 50. Okay, so we have a demand on distribution centers, and the capacity, the number of products can be produced by each plant is also given. Now we can see here that the transportation costs taken by each product to send it to from plant A to plant distribution center 1 is $3. Okay, similarly for plant A to distribution center 2 is $1, and plant A to distribution 3 is $9. Okay, this is the cost table which gives what is the cost involved from a particular plant to the distribution center. Okay, so this is our problem, and we want to minimize the overall cost by allocating or finding how many products needs to be sent from each plant to each distribution center. Okay, so for example, if plant A's capacity is 50, we can split plant A's capacity to probably 20 to DC1, 10 to DC2 and another 20 to DC3, so that the overall cost, similarly for plant B, also for plant C, finally the overall cost must be the minimum. Okay, so how to solve this? Any problem like this to be solved in Excel must be the first step is to formulate the problem properly in the Excel worksheet. Okay, that is the main key to solve any transportation problem or any simplex problem. Okay, so in this case what I'm going to do is I'm going to formulate the problem in the same way how it is appearing here, and then I will show you how we can solve the problem. Okay, what I have here is I'm going to first find the changing variables, or the variables what we want to, how many products from plant A to DC1. Okay, it's going to be here. Okay, so I first set the changing variable matrix. It's similar to the cost table. Okay, this is a variable table. Okay, I take it the same format: plant A, plant B, plant C, and DC1, DC2 and DC3. Okay, this is the variable matrix. In the variable matrix you will see each cell here will represent the product needs to be found out, okay, or optimized to check how many products from plant A to DC1. Okay, the solution is going to come here. Okay, this is our objective, where we'll get the variables. We want how many products from plant A to DC1, how many from plant A to DC2 and plant A to DC3. Okay, these are all called the variables, or in here in Excel we will call them as changing variables. Okay, these are all changing variables. This is the solution we want to get it. okay. And okay, this once we say this is a solution, then what are the constraints? Okay, constraints is nothing but we have the capacities for each plant is restricted by the capacity. Okay, what is our capacity here is the 50, 70 and 30. Plant A can have only 50 and plant B can have 70 products can be produced from plant B, and plant C is 30 products. Okay, if that is the case, what we are going to have, we are going to split the constraint into left hand side and right hand side. Okay, so left hand side is the left hand side and the right hand side. So we are going to see the capacity constraints. What is the capacity constraint? The products produced and send it to DC1, DC2 and DC3 from the plant A cannot be more than 50, because the capacity of this plant is only 50. So the sum of all the products send it from plant A to DC1, DC2 and DC3 is equal to 50. That is the constraint. Okay, sum of all the products send it from plant A to all the DCs or the left hand side of the constraint, which is supposed to be equal to 50. Similarly, for the plant B, the sum of all the product from plant B to DC1, DC2 and DC3 supposed to be equal to 70. Okay, this is left hand side, the sum equal to the right hand side, 70. Okay, similarly the sum of all the products send it to DC1, DC2 and DC3 must be equal to 30. Okay, so we are not going to do individually the constraints. We already preparing the left hand side and the right hand side of the constraints. Okay, these are all capacity constraints. Okay, what about the demands constraints? Okay, demands also here, they also have left hand side and right hand side. Okay, this is right hand side, demands constraints. Left hand side is what? Okay, the demand from DC1 distribution center is only 70. So the products which we get it from all three plants to DC1 must be equal to 70. The same thing. So the column wise sum of DC1 cannot be more than 70, because the demand itself is 70. Okay, so the plant 1 plus plant B's products plus plant C's product, the overall products which sent to DC1 is 70. Okay, so left hand side is the sum, right hand side is equal to 70. Okay, similarly the sum of the products from all the three plants to DC2 is equal to 30. Similarly, sum of the products sent it from all three plants, plant A, plant B and plant C to DC3 is equal to 50. This is left hand side and this is right hand side. Okay, so we have three capacity constraints and three demand constraints. Okay, and what we have is change variables. This is what we are going to get the values, how many products from each plant to each distribution center. Okay, and now finally we are going to come to objective function. What is our objective function? Objective function is obviously to minimize something. Okay, minimize the cost. Okay, so the overall cost we are going to minimize. Then how can we get the overall cost? So plant A to plant A to distribution center unit cost is 3. So per unit cost into what we are going to get the number of products, the variable, okay, will give you the overall cost for plant A to DC1. Similarly, for the unit cost of plant A to DC2 into the product number of products we are going to find out, okay, will give the overall cost of plant A to DC2, the total cost. Okay, similarly all the costs added together will give the overall cost. That cost we are going to minimize. Okay, so basically the cost coefficients must be multiplied by, each unit cost must be multiplied by the number of products and added for each cell. Okay, which is nothing but this product, individual cell, respective cell must be multiplied and added. Okay, so now you must know the sum product function. Okay, sum product function is very simple. You have three values for array 1, and array 2 you have three values. Then what sum product will do is, if you pass the array 1 and array 2, it will do the corresponding elements multiplication. Okay, products. Okay, so it will multiply this by array 2's first element. Okay, similarly, okay, I will do this way. First it will do the first elements product, then it will do the second elements array 2, array 1's second element into array 2's second element. Similarly, array 1's third element into array 2's third element. Okay, it will do the corresponding product. Finally it will give you the sum. Okay, sum of all the products. That's why it is called sum product 32. Okay, now I will do the sum product. Okay, the array 1 I will pass comma array 2. Okay, it will give the answer. Okay, so you keep in mind that you have array 1 and array 2, both arrays of same size, then it will do the corresponding element multiplication and add the sum total. Okay, finally it will give the sum of products. It do the product of each element, and finally it will corresponding element and give the sum of all those products. Okay, now come here. What we are going to do here is, we are going to use the cost per unit cost into the number of products. Similarly, for each element we are going to multiply and get the cost of each plant to that distribution center. Finally we want the total of all the costs to be added, all the products to be added. Okay, which is similar to our sum product function. So I am going to use the sum product function here. Sum product of, okay, first is cost coefficients, that is per unit cost matrix, and then the variables, number of products we are going to find out. Okay, so I am passing two arrays. It will automatically multiply and give the sum product. Okay, if you cannot understand this way, you can also do step by step in this way. Okay, first element unit cost into the plant A to DC1 total number of products we are going to find out, plus similarly DC2, similarly for the per unit cost for plant A to DC2 into the total number of costs from plant A to total number of products from plant A to DC2. something like this. So you keep on adding. Okay, this is what simplified in some product function. Okay, so if you are still you need some help from some product functions, so you can refer my previous videos. You can find a lot of some product examples are there. Okay, so for time being we are passing two arrays. It will do them corresponding element multiplication. Okay, then it automatically gives the individual cells total cost. Then we want overall cost. Okay, that is this. Okay, now we are going to solve by now we are set everything ready, constraints, changing variables and objective function. We are going to solve it by LP. Okay, how we are going to solve? We are going to solve the solver. Okay, so we are going to use the solver. Solver will be in data tab. Okay, there will be a group called analyze, but it is not here because I haven't added the add-in. Okay, if you don't have, how can we add the add-in, solver add-in? We can go to file, go to options. In the options you can see add-ins. In the add-ins you can see solver add-in is already installed, is there. So you go there, Excel add-ins, go manage Excel add-ins, go here, solver add-ins, check it. Okay, okay, you can find the solver is coming here, analyze solver. Okay, interesting. Now what we are going to do is click on solver. I'll reset all the values now. Okay, what I am going to do to set objective, my objective cell is already is here. Fine, so I click my objective cell. Okay, so my objective cell is already here, and what is, which is this cell K2, and what is my objective? To minimize. Okay, so objective is set. Now my changing variable cells, the variables what I am going to find the number of products from each plant to distribution centers. So click, I just select, this is my changing variable cells. Okay, finally the constraints, what I must do, I add constraints. So I must add this LHS, which is the first capacity constraint. LHS must be equal to, this must be equal to the capacity of all the plant A to all the distribution center. That is, we already calculated, is here. Okay, the LHS side equal to RHS. Okay, 50 is here, must be equal to 50. Okay, then add similarly this LHS second plant B's capacity constraint must be equal to RHS values here 70. Okay, add similarly third one equal to 30. Okay, instead of adding this way 3 constraints for each capacity constraint, since it is in the array type, we can simply add a array. So solver accepts that type of adding constraints. So what I'm going to do, I just delete and show you, instead of adding one by one, I'm adding a array constraint. Okay, okay, so what I'm going to do, I'm going to add a full constraint, all 3 constraint into one shot, which is all LHS equal to the array of LHS equal to array of RHS for capacity constraints. Add. Okay, this is nothing but 3 constraints in a matrix form. Okay, similarly the demand constraints, all LHS of demands each distribution center demand is equal to, already given here, the demands RHS. Okay, press OK. We added these two constraints. Okay, make unconstrained variable non-negative. That means the number of products, this changing variables, all positive or equal to 0. Okay, we don't have a negative supply. Okay, so we have number of products equal to greater than or equal to 0. Okay, then select a solving method is LP. Okay, the options is also here. You can change how many iterations you want or maximum time you want to set it for a algorithm to run, all those stuff. Okay, but the initially for the default values are okay for me, and if you need a specific thing, you can very well read the solver instructions or manuals and the help part, and you set it according to that, the precisions and time limit and iteration, how many you want. If you have a very big problem, you can set the iterations and all. Okay, so for the all methods, also non-linear, evolutionary, but this one is a simplex method. Okay, then I am not changing anything for the options time being. I just keep it the default simplex. Now I am going to solve the problem. Okay, everything I put it, I run it. Objective cell must be a formula. Okay, I already put a formula. What happens here? Okay, K2 some product of, okay, it's a formula. I already added a formula. Okay, now it is solver found a solution. Why the error came? Because the objective, I am not clicking here, I clicked somewhere else. Okay, in the objective function cell. Okay, so now keep solver solution. You have solver found a solution. You can also have the reports if you want. Okay, and you can see the reports. It will give you the answer report, what is the value it found, final value, what are all the constraints, all descriptive, all those stuff. You can go through it slowly. Okay, and also the sensitivity report. Okay, what is the final value, reduce cost, and shadow price, constraints, right hand side, left hand side, all those stuff. Okay, and the limits. So you can please go through the reports if you want, but I'm more on the solution part. Okay, now it found a solution. 20 products must be from plant A to DC1 and 30 products from plant A to DC2. Okay, so overall products it produce plant A is 50. Okay, the capacity is also 50, so it solves the problem. 50 from plant B to DC1 and plant B to DC3 is 20. Plant B to DC2 is 0. Okay, no product to be sent from plant B to DC2. Okay, this way we have the solution, and we have the capacity, and capacity left hand side, right hand side is matched properly, and also the demand also matched properly. 70 for DC1, DC2 and DC3. So plant A and plant B together send 70, which is the demand for DC1. Plant A itself is sending 30 demand of DC2, and plant B and C will send 50, 20 and 30, 50. Okay, so this way the minimum cost is 460. Okay, so the minimum cost we had is 460. Okay, if you send this way the sources to the supply, the demand, the supply and supply to the demand, you will get only $460. Okay, I hope this video is helpful to you for the fun part. Okay, if we don't have this transportation problem, what is the risk of having a maximum cost? Let's see. Okay, data, solve. The answer now is 460. Okay, I have a maximum I press OK. You see, if you don't have, there is a risk that I maximize the problem. Okay, not minimize, maximize. I got $880. Okay, 460 is minimum cost, maximum cost of $880. If you don't have such decision problems, you may send plant A to DC350 and plant A plant B to DC1 DC2 40 and 30, then the overall cost may be $880. There is a risk of you sending almost double of your cost. So the actual solution is, we will move to minimum and press solve. Okay, 460 is the answer and we solved it. This is the answer. Number of products we need to supply from plant A to DC1 and DC2, similarly for B to DC1 and DC3, and plant C to DC3. Okay, and overall cost we will get it is 460. Hope you like the solution as well as the formulation of the problem, and hope my video is helpful to you. And if you like my video, please subscribe to my channel. You already found the Alan Sam button is already there in this screen. You can press and subscribe to it, and leave your comments and suggestions and also the improvements. Okay, I really value your improvements and your valuable suggestions to improve my videos and the solutions. Okay, and God bless you.